Okay, the last transformation is rotations, and it's just like you would think about it. Okay, rotation is to turn, so turning a shape. So it's either going to be 90 degrees, 180 degrees, or 270 degrees. Okay, 360 degrees, if you go 360 degrees, you are going to end up in the exact same spot you started with. Okay, so we don't ever really talk about 360, but that's something you guys need to know. 360 degrees is a full rotation. Okay, you're going to end up exactly where you started. So if that's a full rotation, then 180 is the exact opposite. Okay, so those are the two easiest. Clockwise, just like a clock works, just like the second hand moves to the right. Okay, so that means counterclockwise, you're moving to the left. So if we go 90 degrees clockwise, we're going one turn to the right. 180 degrees is 2 turns to the right. 270 degrees is 1, 2, 3 to the right. So if we have a coordinate plane, we have our coordinate plane. If you are starting here and you go 90 degrees clockwise, that's 1, 90 degrees, 2 turns, 180 degrees, and 3 turns, 270 degrees. Okay, so if this is your starting point. Okay, so then that's clockwise. If we go the other way and say we start here, we go 90 degrees counterclockwise. Counterclockwise, I'm going to put CCW. 180 is the same. And 270 would be 3 turns. Okay. You can go back and look at the other rotations notes and look at the rules. This is going to be more looking at the graphs. Okay, so the other one was the rules. If you want to remember the flip, don't flip, that's perfect. I would study those and write those down. And then this is the graph version. So you can determine which section the shape should land in, kind of like we did on reflections. So example 1, the coordinate grid shows triangle XYZ. Triangle XYZ is rotated 90 degrees clockwise. So clockwise means we're moving to the right. 90 degrees tells us we're moving one time. To create XYZ, which rule describes the transformation? So say we start with Z, and we want to move it here, okay? 1 rotation to the right. So that means your new Z point should be in quadrant 4. So let's start with Z, and it's at, we'll say 1 and 3, just to make it easier. 1 and 3. Okay, so let's check our answer choices. A says that we flip them, and that would give us 3, 1. So let's try that. Where's 3, 1? So 3, 1. Okay, is that the right coordinate we want? No. Or the right quadrant. I mean, we want it to be in quadrant 4. So A is not going to work. Let's try B. So it says they flip them. So that means we're going to have 3 and 1 again. But your X value, the sign in front changes. So now it's 3, -1. So 3, -1. Is that the right quadrant we want it in? Yes. So maybe. Okay. I'm going to put a little blue. Okay. C, X, -Y. So that means we would have 1 and 3 in the same order, but now my Y value has the sign changed in front. So now it's negative instead of positive. So 1, -3. 1, 2, 3. So is that the right quadrant? Yes. So let's maybe put a little mark by here, and then let's check D. So X and Y stays in the same order, except my X value now turns negative. -1. So -1, +3 would be up here. Not the right quadrant, so D is out. So now we need to decide between B and C. And what you can do is you can go ahead and plot these other points and see which one looks like a rotation. Or go back and look at your rules. Okay, so if it's a rotation of 90 degrees, your X and your Y flip. Okay, so which of these shows X and Y flipping? B. Okay, remember that. But it's worked out here, step 2, step 3. Okay, so it kind of shows you step 2 and step 3, write the answer choice for each one. So if you were to plot these, if we go back and we get rid of A, we get rid of D, and we plot these points just to show you how you can use this. Let's look at B. We'll plot B first. Okay, we'll do that real quick. Okay, so I went back and plotted B and C. So B is the red, C is the blue. And so which of these looks more like a rotation where your shape actually turns? Okay, so Z, or your red one, B, is going to look like a turn, where Z is in a totally different location. The blue is more of a reflection. They're all kind of in the same spot. They're just using X as the mirror. Okay, so just double check in here. It's going to be B. Okay, next example, triangle DEF is rotated 270 degrees counterclockwise. Let's to the left 3 times to create triangle D prime, E prime, F prime. If point E of triangle DEF is negative FG, so negative X, Y, which algebraic representation best describes point E prime? So if this is E, we're going to figure out what E prime is going to be. So they give us just examples. So A would be Y negative X, Y positive X. Oh, yeah, that's right. X negative Y, X minus 270, Y minus 270. Already we can get rid of D, because if you're subtracting anything from your X and your Y, that's a translation. Okay, so it's not a rotation. So if we make up a point, if we just make up a point for E, since they didn't give us any actual numbers, let's say E is 4, 5, negative 4, 5. We'll say that. So negative 4, 5, negative 4, 5 is our E, our original E. And we want to see which one would be counterclockwise 1, 2, 3. So E prime should be somewhere over here. So let's see if this will work for us. Okay, so if E originally is negative 4, 5, let's write that down over here. Negative 4, 5, and remember we just made that up so we can test it on our graph. So let's see if we rewrite the coordinates for each answer choice. So if we take negative 4 and use answer choice A, so it says Y negative X, that means these flip. So 5, negative 4, but it says the X, the sign in front changes, so we're going to erase that. So 5 and 4. So come back up on your graph, 5, positive 1, 2, 3, 4. Okay, is that the right quadrant that it should be in? Yes, I'm going to put a check mark and then we can check the rest of them. So negative 4, 5, B says they flip. 5, negative 4, and nothing changes. So 5, negative 1, 2, 3, 4. Okay, so that's answer choice B. Is that in the right quadrant? No. And then C says they didn't flip around. Negative 4, 5. The only thing that changed is the sign in front of the Y value. So negative 4, negative 5, which would be right here. Okay, so again, is that the right quadrant it should be in? Nope, it should be up here. So your answer should be A. And again, if you can remember those rules, if you go back to that first, the last rotations notes, if you can remember those, then that'll help too. If not, use this graphing. You can always make up points. Next example, QRS is shown below. If QRS is transformed to create Q prime, R prime, S prime, and the coordinates of Q prime, R prime, S prime are Q, negative X, negative Y, negative X, negative Y, negative X, negative Y. Which transformation has occurred? So on these, I would just get rid of kind of the obvious ones. So if you're going from X and Y to negative X, negative Y, you're saying that it's the exact opposite of what the original point was. Okay, so if R is at 6, 8, then that means it would be translated to be negative 6, negative 8, negative 6, negative 8. And then S would be 9 and 2, so that would be translated negative 9, negative 2, negative 9, negative 2. And then Q is at 3, 2, so with this translation, negative 3, negative 2, negative 3, negative 2. Okay, so can you kind of see what has happened? Is it a reflection across the y-axis? So let's look. If it was a reflection across the y-axis, it would be a straight mirror to that one. That would mean this should be R, this should be S, this should be Q, like you're looking in a mirror. Okay, that's not what happened. Then B, rotation of 90 degrees clockwise. If it was a rotation of 90 clockwise, it would be one turn, and it would be in this quadrant. Not going to be B. Reflection across the x-axis, that means it would be the exact mirror shape in this quadrant. That's not what we have. So it's got to be a rotation of 180 degrees. And again, if you can remember that rule, then you were good to go. But if not, check on the graph. Last example, this one down here. The coordinates of the vertices of a quadrilateral A, B, C, D are shown if E, oh, hold on. Let's ignore this. Quadrilateral E, F, G, H is rotated 90 degrees counterclockwise, so that's one turn. One turn to the left to create A prime, B prime, C prime, D prime. Which rule describes this transformation? This one, I would kind of remember those rules. Actually, I'm going to erase this graph because I'm not going to use this. Remember those rules. If not, then let's just use... Oh, okay, I gotcha. So E, F, G, H is the transformed version of these. So let's start with A, 1, negative 4 to get to E. And we want it to be rotated clockwise 90 degrees. Okay, so let's see. A is 1, negative 4. So if we rotate this 90 degrees counterclockwise, that's one turn to the left. So we want this to be over here. So it's going to be in quadrant 3. So let's check these answer choices and see which one will give us an option in quadrant 3. So A says y negative x. So that means negative 4 and 1. They flipped them around and they changed the sign in front of the 1. So negative 4, negative 1. So negative 4, negative 1. Okay, so is that the right quadrant? Yes, let's check the other ones just to make sure. B, negative yx. So they flip them, and your y, the sign in front changes. So I'm going to erase that negative in front of the 4. Okay, so now it's 4, positive 1. Okay, so that puts me up here in quadrant 1. Is that correct? Nope. So then let's look at C, 1, negative 4. So they stay in the same order. So 1, negative 4, but the sign in front of that y changes. So I'm going to erase that negative. So it's positive 1, positive 4. So positive 1, positive 4 up here. So again, it's in quadrant 1. That's not the right spot we want it to be in. D, negative x, y. So they're in the same order. 1, negative 4. But the x value, the sign in front changes. So negative 1, negative 4. So that'd be way down there. So between A and D, we're going to have to go with A. Because D, although it's in the right quadrant, it's directly across from that A, that point. Okay, it's not going to ever look like that when you've got rotations, if it's rotated. This would be probably a reflection because it's the exact the exact spacing away from your original point. Okay, that's never going to be the case with rotations. They're always going to be turning and moving. Okay, so we're going to go with A. And that's one you need to check those rules. Look back on when it's 90 or 270 degrees rotated. The X and the Y always switch spots. X and the Y didn't switch spots here.